Hi, everybody. Welcome to the webinar about what's new with Amazon DynamoDB. My name is Eden Zulich, and I'm a NoSQL Solutions Architect at AWS focusing on DynamoDB. The agenda for this webinar, after a quick overview of Amazon DynamoDB, we're going to jump right into it. So let's start with that. DynamoDB is a fully managed NoSQL database. At its core, it is a key value store that also has a document API. DynamoDB is not the only or first NoSQL database developed at Amazon. This year actually marks the 10th anniversary of the Dynamo paper, which describes one of the first NoSQL databases and principles that it was built on. Dynamo was created to address growing scalability and reliability requirements of the Amazon's e-commerce platform. It was targeted at use cases that were core to the Amazon e-commerce operation, such as the shopping cart and session service. So any downtime or performance degradation in these services would have an immediate financial impact. So in addition to scalability, the fault tolerance and performance requirements for Dynamo were very strict. Another important requirement was predictability, both in terms of performance and cost. And while Dynamo delivered extremely well on these requirements, it was not easy to use. Managing clusters of distributed systems was not an easy task, and it still is not today. So around the same time, another database was created at Amazon. That was Amazon SimpleDB. SimpleDB was a fully managed service, like Amazon S3. Developers loved it for that reason. It was much easier to use than Dynamo. So DynamoDB builds on the best ideas behind these technologies and on the years of experience developing and running non-relational databases and cloud services at scale. And today, when we look at the features that Amazon DynamoDB was built to provide, we examine the new features and we see that these new features will still deliver and improve on the original benefits of DynamoDB. So the operational overhead of NoSQL databases remains very important task, and so DynamoDB is dedicated to delivering a fully managed service that makes it easy to use. Also, as far as performance, you can expect single-digit milliseconds both for reads and writes in DynamoDB. The scalability is provided by sharding your data and volume across many partitions, as many as needed. And at the same time, Dynamo also replicates data 3 ways in 3 separate physical facilities so that you have high availability as well as durability. It also delivers flexible data model as well as consistency model. The consistency model can be controlled on a per request basis, such as that when you make a read request, you can specify if you want that read to be eventually consistent. Cost effectiveness was another key component in all this. The idea being that as you scale your volume and throughput, your cost should grow proportionally to that. And for security, DynamoDB is fully integrated with AWS Identity and Access Management. So let's take a look at the features that are new this year. Cost allocation tagging provides insight into the spend of your DynamoDB resources, and it allows you to tag your DynamoDB tables, DAX clusters with meaningful tags that you can then use in the billing console and cost explorer to filter and analyze your cost accordingly. Let's take a quick look at the console to see how that works. I have a couple of tables here that are part of the same application that I tagged accordingly as app name sensor data. And I'm going to switch over to the billing console. and make sure that my cost allocation tag is active. Right here, it shows that its status is active. If it weren't, I would simply select the tag and activate it. I can go now to Cost Explorer. I'm going to choose one of the pre-configured views, in this case, monthly spend by service view, which will show what services I've used in the last 3 months and what the cost of those services is. Now, I'm really just interested in my application sensor data, so I'm going to select that tag, sensor data, and I have to scroll down to apply the filter. And now I'm really just looking at the cost of my application sensor data over the 3-month period. That's as simple as that. Some things to know about tagging. Indexes are tagged automatically as their parent tables, so there's no need to worry about tagging your global secondary indexes. Dynamo DB streams currently cannot be tagged. There's a limit on maximum number of tags per resource, it's 50. Keys and values are both case sensitive. And tagging is a separate action, so you cannot tag a resource such as DynamoDB table at the creation time. Time to live. This is a feature that offers the ability to expire your data when it's not needed in DynamoDB anymore. On expiration, DynamoDB will automatically delete expired data. The benefits of this feature are twofold. One, it allows you to manage the lifecycle of your data in DynamoDB. And second, it helps reduce costs by deleting items that are no longer needed and in a way that does not consume write capacity in DynamoDB. If you were to delete data using delete item operation, that would consume write capacity. Deleting based on TTL does not, so that's another added benefit. Let's take a quick look in the console. We're going to go back to the DynamoDB console and show how easy it is to enable TTL. I have a table, foo, which has just a few items, and I've already created an attribute named TTL. In my case, it could be any name that you like. As you notice, I'm going to open up this item real quick. The type is number, and the format is Unix epoch format. Those are requirements for TTL. Now I can go to the overview and click on Manage TTL. I'm going to specify my TTL attribute. This dialog also allows me to enable DynamoDB streams, which in my case are already enabled, and also run preview to see which items might be affected by TTL and already expired. And here we go. So TTL is enabled, and that's all it takes. One additional benefit to TTL is that events that were caused by TTL, so deletions based on TTL, can be filtered on in DynamoDB streams. So you can have a way of archiving or otherwise post-processing TTL deleted data. In this case, we're archiving data that is deleted by TTL to S3. Some things to know. Expired items are deleted within 48 hours of expiration. So even though you have a specific expiration time, the background process that sweeps your data in DynamoDB runs asynchronously, and it might take up to 48 hours to delete expired items. So if your requests need to return items that have not been expired, in other words, if you don't want to return items that have been expired, you'll need to make sure to filter those, and that can be done using filter expressions. A couple of other things to note. Access to TTL can be controlled using IAM policies and DynamoDB update time to live action. And again, probably the most important, the designated TTL attribute has to be number type and in epoch format. Autoscaling. The main benefit of autoscaling is to make it easy to ensure that your tables have enough capacity when they need it. Another additional benefit of this feature is reducing the cost by reducing the capacity when it's not needed. This is a fully managed and automatic scaling of read and write capacity of tables as well as global secondary indexes. Let's take a look in the console to see how it works. If I'm creating a new table, autoscaling will be enabled by default. Let's say that I have a table orders, and if I just stick with the default settings, I will have autoscaling capacity set to 70% target utilization and some minimum and maximum capacity settings. Now, if I don't want to use the defaults, I can simply unselect that option and then change the settings. Target utilization tells DynamoDB how to control the provision capacity. It basically 70% means that consumed capacity should be at the 70% of provision capacity. And that's really all it takes. I can go ahead and create this table with these settings. While that's going on, we can continue with the overview. So in this example, we show how autoscaling changed the provision capacity to handle the load in a 3-hour period. And we see that initially the consumed capacity was about a couple of thousand writes per second, and over about 2.5 to 3 hours, it went up to over 60,000 requests per second. And autoscaling just automatically changed the provision capacity accordingly. Some things to know about autoscaling. One, it is well suited for gradual changes in traffic volume. So if you have spikes in your workload that are significant, that are not going to be handled by burst capacity in DynamoDB, autoscaling is not going to be able to address those, to handle those quickly. For known traffic patterns, one approach that we recommend is to disable autoscaling and use update table API directly to provision capacity. In case of read bursts, such as unpredictable high volume read bursts, consider using DAX instead. Another thing to note is that capacity can be decreased up to 9 times per day, once every hour for the first 4 hours, and then once every 4 hours for the rest of the day. There is no limit on the number of increases, and that's in line with the original goal for autoscaling, which really puts the ability to have capacity that you need at the first place, and then the ability to decrease capacity when you don't need it second. It's best to use the same autoscaling configuration for global secondary indexes as for their associated tables. That's in fact on by default. I would also recommend checking out application autoscaling API, which now supports disable scaling option for DynamoDB. If you use disable scaling, DynamoDB autoscaling will not reduce capacity. So it will only work to increase capacity as needed. DynamoDB Accelerator, or DAX for short, is a fully managed front-end cache for DynamoDB. It's targeting read use cases for DynamoDB. One use case is read performance. If you need microseconds response times, that DAX would be a good option to use. Also, if you need high volume of read requests, DAX can handle millions of reads from a single DAX cluster. DAX can also work to reduce provisioned read capacity for your tables, and that's another consideration to keep in mind. So as far as features, it's fully managed and highly available. This is configurable. You get to choose the instance type and the number of replicas in your DAX cluster. The API for DAX is fully compatible with DynamoDB API. It's flexible, and um, you can use DAX in multiple configurations, either one cluster per table or multiple tables per cluster, and so on. You can also continue to call DynamoDB APIs directly. So in your client, you can use both DAX client and DynamoDB client concurrently if needed. Dynamo DB Accelerator can scale out up to 10 read replicas, and it's a fully integrated AWS service, and of course, it's secure. It uses IAM. So use DAX if you need extremely low read latency. DAX will reduce DynamoDB latency by an order of magnitude, so sub-millisecond response times, and read scale, so high read volume. If you have unpredictable read spikes, DAX is a good option. So to compare DAX against the traditional side cache, which requires applications to use both caching as well as database APIs. DAX is an inline cache, and it's a write-through cache as well. So DAX API is the only API that you need to use when you're reading or writing data from DynamoDB through DAX. And so that simplifies your application development in addition to the other benefits. This example shows the read performance benefit of DAX. Without DAX, we see that get item calls are taking about 4 to 5 milliseconds. With DAX, that goes down to 2 to 300 microseconds. Scalability can be controlled in a couple of ways. The size of cache is controlled by the selection of instance, and instances can scale up to 244 gigabytes. As far as scaling out for read volume, you can scale out up to 10 read replicas. Caches supported by DAX are item cache, which serves get item and put item requests, and query cache, which serves query and scan calls. These can be, in terms of eviction and controlling lifecycle of data in DAX, you can configure time to live for data that's cached in DAX. DAX also uses LRU, least recently used algorithm, and write-through eviction as well. To integrate DAX in your application, you simply comment out your DynamoDB client and replace it with the DAX client. Let's take a quick look in the console to see what it takes to create a DAX cluster. We can name it whichever way we want. In this case, cluster 1, and select the node type. At this time, only R3 instances are available. We have the option of selecting cluster size up to 10 instances. For high availability and reliability, we should at least have 3 nodes in the cluster. Here we can choose an existing role or create a new one, name it, and then select a policy. And the next section is about VPC configuration, as DAX is a VPC construct. So you can create a new subnet group or choose an existing one, as well as security group, and configure some additional settings, such as cache eviction, TTL for cache eviction, preference for availability zones, parameter groups. If you create a new parameter group, that will allow you to control the query and item TTL, and then the maintenance window. DAX requires 30-minute maintenance window a week, but you have a choice of selecting the time and day of the maintenance window. Now, during the maintenance window, DAX will remain available. And that's all it takes to create a DAX cluster. Some things to know. Currently, only Java SDK is supported. Support for other SDKs is in the works. And as far as currently available regions, those are North Virginia, Oregon, Ireland, Tokyo, and North California. Other regions are also coming. Instances supported are 3 currently, and just recently, CloudFormation support was just added. Next, VPC endpoints for DynamoDB. VPC endpoints enable access to the service, in this case DynamoDB, via secure and private Amazon VPC connection that does not leave Amazon network. It also allows you to customize access for each VPC endpoint using IAM roles and policies. So you can create one or more VPC endpoints and customize each one for a specific use case or application. Some of the benefits of using VPC endpoints, of course, in addition to enhancing your security and privacy of your connections, data connections to DynamoDB, it basically makes your network configuration that much simpler because you don't have to configure Internet Gateway or NAT Gateway to communicate with DynamoDB. And that also means cost savings because you don't have to incur the cost of using NAT Gateway. Some things to know about VPC endpoints. There are some general endpoint limitations. So endpoints are supported for IPv4 traffic only. The connections cannot be extended out of a VPC, and endpoints cannot be transferred to another VPC or service. At this time, DynamoDB streams cannot be accessed via endpoints. And also, good to know that the VPC endpoints support traffic within the same region, so cross-region traffic is not supported. You can also customize your access policy for your specific needs. So for example, you can have a VPC endpoint that's configured for the needs of a specific use case or application, so it only accesses those tables in DynamoDB required by that application. You can also use AWS source VPC-E condition to restrict access based on VPC. Finally, one last feature that I will talk about is actually technically not a DynamoDB feature. It's a data migration service feature. Now, if you're new to data migration service, it essentially helps migrate data to AWS. This service now supports DynamoDB as a migration target, and that means that you can migrate your data from any available source database, which could be any supported relational database, as well as MongoDB to DynamoDB. And for more information about these new features, refer to the DynamoDB documentation, which is very detailed. And of course, we are here to help anytime you have any questions. And finally, thank you for attending this webinar. We'll take some time to address some of the questions that have come through. And we can start with some of the auto-scaling questions. First, how is the cost of usage decided? Do we get charged only for the consumed RCUs and WCUs? So do we get charged only for the consumed write and read capacity? The cost is calculated based on provision capacity, not consumed. So as auto-scaling changes provision capacity, the cost changes accordingly. Is auto-scaling available in all regions? Yes, auto-scaling is generally available in all regions. Here's a DAX question about maintenance window. How does maintenance window work? For example, is the cluster down or available during the maintenance window? So the cluster is available during maintenance windows as the nodes are taken offline one at a time. In one node clusters, an extra node is provisioned during maintenance at no extra cost in order to maintain availability. Another DAX question. Can you take advantage of DAX from Lambda calls? Yes. However, since DAX runs inside your VPC, you will need to configure Lambda function to run inside that VPC as well. Let's see. Another DAX-related question. What is the difference between Elasticache and DAX? So Elasticache exposes Redis or Memcached API. If you use Elasticache, you have to use it as side cache and make separate calls to the cache and then separate calls to DynamoDB. DAX, on the other hand, is an inline cache that exposes Dynamo DB API and provides caching transparently. So with DAX, you don't have to write caching logic as you would with Elasticache. Back to autoscaling. Is there an additional cost to use autoscaling? No, there is no additional cost beyond what you already pay for DynamoDB and CloudWatch alarms. In fact, depending on your workload patterns, autoscaling can help reduce costs significantly. Let's see, VPC Endpoints. Question, can I access DynamoDB streams through VPC Endpoint? And the answer is no. Currently, DynamoDB streams cannot be accessed via endpoints. Another VPC Endpoints question. Do VPC endpoints limit throughput to DynamoDB? No, endpoints do not affect throughput in any way. And let's see, go back to autoscaling again. I think, that was a DAX question, sorry. Is the TTL for DAX the same as TTL for DynamoDB? No, in fact, DAX TTL is different. DAX TTL only controls the time to live of your data in DAX, so it has nothing to do, does not interact with the TTL for DynamoDB. Another VPC endpoints related question. Can I have multiple endpoints for DynamoDB in the same VPC? Yes, for example, different endpoints can be used with different access policies for different purposes. However, a single route table in a VPC can only be associated with a single endpoint. Here's a tagging question. Can tags be applied to tables retroactively? The answer is no. Tags begin to track data from the date they are applied, so they cannot be applied retroactively. A TTL related question. Is there a way to find out if TTL is enabled for a table? Yes, there is. There is an API call, describe time to live, which will return the status of TTL for this table specified. You can also see if TTL is enabled for a table in the console as well by going to the DynamoDB console and selecting the Overview tab. There will be an option to manage TTL. That's all the questions we've had. Again, thank you very much for participating in the webinar about new features in DynamoDB. And the DynamoDB service team is continuing to work on new features, so stay tuned. Thank you.